Let us look at the graph of y equals sine theta, right? You probably would have seen this graph already. You know that the sine wave of the graph of y equals sine theta is shaped somewhat like this, right? What we want to do is see how we actually plot the values. Now, remember, you have the angles theta running along here, and then sine theta, you have 0 going up to 1, 0 going down to -1. Alright? So, remember now, if we have our right angle triangle, if I can get a right angle triangle here, alright? And let me turn it the other way. This is our right angled triangle. The angle here, angle theta. Okay. Now, remember, the sine of theta is the opposite divided by the length of the hypotenuse, length of the opposite divided by the length of the hypotenuse. Alright? Now, what is the sine of 0, angle 0? Well, the thing is, you know, if this was 0, let me get a straight line, this line kind of bent. What you'd have is this. So, the sine of the angle, this angle, is the opposite. How tall is the opposite here? It is 0 divided by the hypotenuse to be up here. 0 divided by whatever the hypotenuse is 0. So the angle is 0. Let us also use our calculator and see what happens with the calculator. Alright. We have our calculator in degree mode because it's degrees we're doing. So the sine of 0 equal 0. Alright. So we plot our first point. 0, 0. Let's come to angle 45 degrees. Let's see something here. No. Where was our, okay. 45 degrees. Now, this particular angle will be such that when you get 45 degrees, that's halfway between 0 and 90. Alright? The opposite you have here on the hypotenuse. What will be that opposite divided by the hypotenuse? In other words, 45 degrees. Let's get back to our calculator. This is our calculator. We find sine of 45 equal 0.707. Alright? So, that's 0.707. Now, 0.707 would be about where? Let me see. About 2.6, 0.8. 0.7 would be halfway between 0.6 and 0.8. So 0.707, almost at the same spot. We plot this here. Now, let's look at 90 degrees. What would be the thing there? the sine of 90 degrees. In that case, our triangle would look like this because the angle is 90 degrees. And remember, angles are measured in an anti-clockwise direction, right? Positive angles generally measured in an anti-clockwise direction. So, our 90 degree, our 90 degrees would look like this. So the hypotenuse would be over this side, and our opposite would be over this side. So the hypotenuse and the opposite would be lying flat together, pointing straight up. So both of them would be the same lengths. So our opposite over hypotenuse would be 1. Let's check our calculator and see. The sine of 45 equals, not 45, 90. The sine of sine 90 degrees equal 1. Alright, so we got that. So in this case, we reach up to 1. Let's look at the sine 135 degrees. What would it be? Interesting. Sine 135 degrees. Now, here. When you talk about 135 degrees, what you're talking about is something like this. Let this thing come up here. You have a circle, which they call it a unit circle because the radius is unity. Which number is unity? You remember? It's 1. Let me bring the circle a bit up here and make it larger. Alright. I want this circle to be a bit larger than it is right now. Alright, now we have our line and we want our angles here. So 135 degrees would be from 0 going up, up, up. Oh, by the way, let me draw the other line here. Oh, something came to mind. Let me use a different color for our line here. So, this 135 degrees, what would it be? What would 135 degree look like? If you swing backwards, you have 45, 90. 90 plus something gives you 135. 90 plus 45 more. So this is 135 degrees. Alright? You know that this sign here means degrees, but let's not put too many things on the screen one time. That's 135 degrees. Guess what? 135 degrees is the same thing as if you swing right around to 180 degrees. Then you go back up and take 45 off it. So 135 degrees is the same as 180 degrees minus 45 degrees. Alright? Same thing. Now, here, you will see that this angle here, this angle is 45. You see that? You see, 45 degrees. Now, suppose, some people say, suppose you have this triangle. No, the 135 degrees in here. And by the way, remember, this unit circle is divided into 4 quadrants. Alright? This space is the first quadrant. This is the second quadrant, the third quadrant, and the fourth quadrant. But the full name is QUADRANT. Remember, quad means 4. So it's 4 parts. So quarter means 4 parts, right? 4 quarts make 1 gallon. So you have quadrant. Alright? When you multiply something like 4, it's quadruple. But anyway, here. Our opposite, you know, is this. This height here is the height of our opposite. And of course, this remains as our hypotenuse. Now, the opposite over the hypotenuse would look the same as if you drew it here. Our opposite be up here on this side, but our opposite here would be the same as the opposite for the 45 degrees. But our opposite over here for the 135, it looks the same as just is on the other side of this line and the hypotenuse. So the sine of 45 degrees will be the same. I mean, the sine of 135 would be the same as the sine of 45. Alright? Let us check it out. Sine 135. The sine of 135 equal 0.707. Aha. So, we got that. That was 0.707. So 135, the sine is just about here. You see that? What about the sine of 180 now? What would that be like? Sine of 180 degrees. Let me do some erasing of things here and look at the sine of 180 degrees. We're going to have to put back our lines here to divide the circle into a 4 quadrant. Alright? Now, if we swing over to 180, because remember again, you measure the angles in an anti-clockwise direction. So you go right here. But then, sine of 180. The triangle that we have would go from this to this to this, right down to this for you to have 180. Remember, we had this triangle, right? And then the triangle, the angle gets larger and it goes around here. Our hypotenuse and our opposite, that's a triangle. And as we go nearer and nearer to 180 until it gets flat. So our opposite would be over here and this would be our hypotenuse, but our opposite is 0. You're measuring the opposite right here, but the height of our opposite, well, it doesn't have any height, it's 0. So the opposite is 0 over the hypotenuse, whatever it is. But remember, 0 over anything is 0. So our sine of 180 will be 0. Let's check our calculator and see. The sine of 180 equal 0. So you see that? So we got our 0. Again. Now let's see the sine of 225 degrees. What would it look like? Well, no. Sine of 225 degrees. Let me erase some of this thing and see what would happen if we try to find the sine of 225. If we start from here and we swing around, so increase to past 45, we go 30, 45, and so on and so forth, and we come here. That would be 90, and we continue swinging, and we go 180 degrees. Now, in order to go to 135, we need to go some more. But how much more? So 135. Oh, it's not 135. Hold on. It's what, 225. 225. Alright. So in order for us to go 225, we'd have to go past 180 and go some more. But how much? 225 equals 180 plus something. Right? Call it x, whatever it is. But x would be 225 minus 180. 225 minus 180 is what? 5 minus 0 is 5. 2 minus 8, you can't borrow 1 from this, you get 12. 8, 9, 10, 11, 12, 45. So you go 45 more. And what you have as your triangle, your hypotenuse would be this. To brush up right here. And our opposite would be this. So you see that? You see what happens there? So this now is our 225 degrees all the way here. Now, this is our opposite, but guess what now? Since our opposite is pointing from here downwards, then our opposite is negative, because this is our opposite. OPP is negative. Alright? Our hypotenuse is here. Our hypotenuse does not change sign. It always remains positive. But remember, when we were going up, it's positive, but now we're going down. So it's negative for our opposite. Now, our opposite over hypotenuse will look like what? Remember, this angle right here, the angle right in here, is 45 degrees, you know. So, the sine of 225 will look like the sine of 45, but it would be negative. Am I correct? Let us see. Sine 225 equal negative 0.707. Alright? So, if we say negative, I have to come down here. Right? Somewhere down here. Between 0.6 and 0.8 negative. And if we scroll across, our negative 0.707 will be right here. So, negative 0.707 will be here. You see that? Alright, 270. We're ready for 270 now. What will be the sine of 270? Let's erase some of what we have here. Now, the thing is, 270 would swing right around to here. Alright? So remember, we would pass 90, then 180, and then 3 times 90, 270. So our angle here would be not 225 anymore, 270 degrees. What's the sine of 270? Well, the thing is, our opposite would be over here, and our hypotenuse would be here. So the fact that the opposite has to run, remember this is 0, the origin, and it goes down means it's negative. The hypotenuse is always positive. So here, what we find is that our sine of 270 will be -1. You bet me it will be -1. Let's see. Sine 270 equals -1. So our sine 270 is -1. So we line up 270 with -1 and we plot. Now what about 315 degrees? 315. What would that look like? We want to look at the diagram before we go to our calculator. So here now it's 315. So I'll get rid of the 270 from now. Get rid of this now. Let's clear some part of the board so we have space to work. Oh, I didn't erase this part. Let's erase the head of this arrow. Now, what was the angle again? My. 315 degrees. Where's 315? Let me see something here. We have 2 pass 90, 180, 270. So we'll reach 270 and go some more, but how much more? When you pass 270, how much more do you go to reach 315? 315 minus 270 equal what? 5 minus 0 is 5. 1 minus 7, you can't borrow 1 from 3, you get 2, 7, 8, 9, 10, 11. Wow, 45 degrees. So, here, what we have is that after we pass 270, then we go 45 degrees more. This little angle here is 45, right? But the thing is, from here all the way around here is 315. So we have our angle as 315 degrees. That means the angle starting here go all the way around here. Now the thing is, where is our opposite when you talk about the triangle? You see, due to the fact that this is 45 degrees, our triangle would be here. So the sine of 45 would somewhat look like the sine of what am I saying? Is the sine of 315 on 1. The sine of 315 degrees would look like the sine of 45, but it would be what? It would be negative, because our opposite has to run down this way. So it is negative. The negative opposite over hypotenuse to give you a negative, so it's negative sine 45. So I bet you that will work. Sine of 315 is going to be negative 0.707. Let's see. Sine 315 equals negative 0.707. So let us plot it and see negative 0.707. Where is negative 0.707? So here. Right, if you line them up, you get this. And then what's the sine of 360 degrees? What would that mean? Well, the thing is, if you go all the way to 360 degrees, it means you're coming right back here. So, your triangle would be this line. You have your hypotenuse, yes, but your opposite is 0, and opposite over hypotenuse would be 0, because if opposite is 0, 0 over any number gives us 0. So what's the sine of 360? Let's use our calculator. The sine of 360 equals 0. Alright? So you go back to 0. Now, you could find angles between them like sine of 30. You get 0.5 and so on and so forth. You could break it up into smaller pieces. Sine of 15, then the sine of 30, then the sine of 45, then the sine of 60, and so on. But I think we have enough points to plot our graph. What will the graph look like? Alright, if we plot a smooth curve, it should be a smooth curve through these points. Let me try to make it in one go, but I won't be able to. But if we do this, we see that that is the shape of y equals sine theta. And if we pass 360, it will only repeat itself. Right? Because once we pass 360, we just repeat ourselves. Like the circle spinning round and round and round, repeating itself. So that's the sine of theta. Alright. I should say the graph of sine theta, which we call a sine wave.